Before we get into VDCs, we need to start with the attributes of a switch in a device. So earlier in lesson 1.1, we covered control plane, data plane, and management plane. When I look at VDCs, it allows me to dedicate control plane, data plane, and management plane on a per VDC basis. And when I enable VDCs, I have allocation of resources of these devices, meaning that I would allocate interfaces into its own virtual device context. We'll get into some use cases. These are use cases that I have in production. It's pretty common across the board for the use cases. So we look at, prod or production, development, DevOps, for example, test networks, the use case for virtual device contexts, intranet, demilitarized zones, DMZ, and some extranet use cases I'm going to cover later through this presentation. But in the book, I covered all the M series and everything prior to F3. Since the book, we've been shipping F3 modules. This is a 48 port, 10 gig F3 module. So here's your 48 ports here. If you look, I color-coded VDC-A to represent blue, VDC-B. So this is what I mean. I allocate specific interfaces into blue. So VDC-A has this group of ports as well as this group of ports in it. And purple, VDC-D, has the purple ports allocated to it. And if I look on the 48 port 10 gig card, groups are allocated in ports of 8. So if you look here, 1, 2, 3, 4, 5, 6, 7, 8. This group of 8 ports has to be allocated to VDC-A. That's how the port ASICs are mapped internally from a hardware point of view into each one of these blocks. Same with this. This next set of 8 goes into there, VDC-B, for example. So on the 12 port 40 gig F3 card, I have 12 ports to work with, but the allocation is done in port groups of 2, meaning that ports 1 and 2 is allocated to VDC-A, ports 3 and 4 is to VDC-B, etc. So I need to allocate the interfaces into a virtual device context in port groups of 2, and that is for the 12 port 40 gig F3 module. If I look at the 24 port 40 gig F3 module, the port allocation is in alignment of port groups of 2 as well, meaning that these two groups are in VDC-A. This just provides guidance when you're going ahead to allocate things. I could allocate what are the rules for the different I/O cards, because each one have different hardware architectures and how you do the VDC allocation. And this is like a decoder ring to sort of help walk you through that. Now, if you didn't want to do any VDCs, you can put this whole I/O card in a single VDC and just have all ports be a member of a common VDC. So if I look at VDC types, again, I'm looking at 626 and higher. So here is a chassis which has different I/O cards, and I can do different types of VDC types. And we've introduced, and I'll go through some examples of different types of like admin VDC versus default VDC. Am I doing mixed mode to where F3 cards can coexist with other cards that you currently have? So from investment protection point of view, I can have M2 or F2 and F2E modules interoperate with F3 cards. This is with 6.2 and higher, or excuse me, 6.26 and higher. But if you notice, there is no support for F3 with M1, M1XL in F3, or F1 in F3. The reasons why I called out the rebind interface, you may need to have the rebind interface when you're adding interop mode with F3 cards. So if I'm doing F2 in F3, I'm going to need to do the rebind interface to enable that. But if I'm taking modules out of that VDC, I'm going to have to do the rebind interface as well. And the F3 does not require the use of a VDC license, meaning that I can just have a common VDC that just has F3 cards altogether. And I'm going to show you what I mean by that. So here I'm going to switch to my PuTTY SSH window, and I'm going to do a where. I want to find out where I'm at. So here, I logged in as admin. I'm on Nexus 7K1 here, which is this host name here. And default means that I'm in the default VDC. Now if I do a show VDC, okay, this is the network-wide switch mode. If I do a show VDC, I see the VDC ID followed by the VDC name. So I'm in VDC1, the device name is 7K1, and this is my line card type here. If I was doing the admin VDC, it would show me of type admin, meaning I do not have the admin VDC created here. It's just the default VDC, and I can treat this as any type of other VDC, meaning that from the default VDC I can still do my control plane policing or COP specific configuration here. If there was an admin VDC, the only interface I would see here, since the admin VDC does not allow any data plane interfaces, meaning it would not see these interfaces here, I would just have type admin and you would see MGMT0 from a management plane point of view. MGMT0 would be the only interface visible in the admin VDC. But since I'm default, I can allocate data plane interfaces into this VDC and make it a VDC type of that. So that's just sort of like the VDC types. If we look at VDC examples, there's different types of VDCs that we can do. I mentioned the F3 prior. I can do an F2E only VDC. I can do an XL only VDC. So if I need large table sizes like internet prefixes, for example, I can do an M2 XL only VDC. And here I'm going to show you this in the command line. So if I do a show mod, these are the different types of physical modules, dedicated I/O modules that are present within the chassis. So remember, Module 2 is an M132, and Module 7 is an F2 card, and Module 3 is an F1 series line card. All these were covered in the prior edition of the book. If I do a show VDC, again, I can see the different VDC types, but more importantly, I want to see the interfaces that are allocated. Show VDC membership. This is where I see, for example, the interfaces. So if you remember, module type 2 was an M132. So if I scroll back up, module 2 was an M132 card. And if I look at that, the port allocation is 1, 3, 5, and 7. So that's the first port group of those 10 gig interfaces. Those are allocated to VDC 1. And I can do a show VDC detail, and I can see all the attributes of this. I can have different HA policy for different VDC types. They can be independent of each other because they are independent. I can have different supervisor switchover or different HA policy between supervisor modules. I can specify the boot order. So these are all different elements that are unique to on a per VDC basis. And here's the VDC supported I/O modules for this VDC 1, which I'm currently in. So if I look at VDC 2, his VDC type supports different line cards. And I see the same thing for VDC 3 and 4 and so forth. If we look at F3 series and interop with existing modules, remember I mentioned we can have F3 and M2 in the same VDC? So I'm here. The thing to call out here is when I intermix these two in the same virtual device context, I go down the least common denominator from a feature set perspective, meaning that F3 in the prior slides talked about Lisp and VXLAN. So when I do F3 and M2 interop, I don't get VXLAN and Lisp. You can see there's an X here. I do get MPLS because there's a common feature set between the two, as well as overlay transport virtualization. And then you see the table here for F3, F2, E, and F2. And if I interoperate them, I get least common denominator. So you sort of get least common denominator from a feature set perspective of, in this case, you're going to get the M2 feature sets, and then here you're going to get the F2 feature sets in this VDC.